Hello, everyone. In this PowerPoint, I'm going to be talking about the muscular system. All right, so the muscular system generates tension on different forces of the body, mainly the bones, to produce movement, helps circulate blood, helps with protection of organs and all other bodily functions. Um, we use it every day, whether we want to or not. Um, Obviously, the muscular system you can train. If you don't train it, can atrophy away, which can kind of break down. You kind of lose all that ability to produce that tension. That tension, whether it's cardiac, that tension in your heart, which just makes your efficiency of your heart to pump go up or down. Okay. There's muscles throughout everything. There's muscles in your veins and arteries. Your organs have some function of muscles. And the biggest one you're going to think of is your skeletal muscles. Okay, so there's three different types. Okay, there's cardiac, okay, skeletal, and then smooth. Okay, we'll get more in depth on some of those here in a minute. Okay, so cardiac, okay, is only found in your heart. Okay, also called your myocardium. Okay, scientific name for your heart. This is your involuntary control. Okay, so your autonomic nervous system controls all your cardiac functions. Because of all the mitochondria in your cardiac muscles, it is very, very resistant to fatigue. Okay, as you can see the pictures here. As I said previously, you can train your cardiac muscles. Your heart can get bigger and stronger and get more efficient at pumping out blood. And as a result, your heart rate will actually decrease because it's just more efficient at pumping out that much blood. Okay. Skeletal muscles. Okay, so this is pretty much be the bulk topic of this PowerPoint. Skeletal muscles attach to your bone via tendon. A tendon is a form of fascia. The fascia is just this really kind of spiderwebby connective tissue that is throughout your body everywhere. And it gets very, very compact in your tendons. But it is encased within and around all your muscles. You'll see the epimysium, perimysium, and endomysium, which are all different forms of fascia. Okay, so these help kind of keep all those muscle fibers and then the muscle itself kind of together, more organized, so it can perform very, very smoothly and efficiently. Okay. So your muscles obviously get broken down in a lot of different fascicles and so forth. I'm not going to get super in depth on some of those right now, in this lecture at least. But they house a significant amount of actin and myosin. Okay. Let's skip one. No. All right. So muscle fiber arrangement. Okay, there's a lot of different kinds of arrangement depending on the need of that muscle. There's kind of four main types. Okay, they're circular. Okay, you'll see here. These are more around like the mouth, the anal sphincter, a lot of different areas which have to close. Okay, very, very good for that. Kind of prevent either air or fluid or whatever item it is from exiting or entering. Okay, there's convergent. Okay, as you see here, like in the pec major. Okay, this is a broad muscle that converges into a single pointer tendon. Okay, so in case of the pec major, what's going to happen is this big broad muscle, it originates kind of this really broad area on the sternum and attaches to this one little spot on the humerus. Okay, so it just kind of converges down to one point. Okay, that's all that is. Next one will be parallel. Okay, as you see in the extensor digitorum longus. Sorry, this is the sartorius. Sorry. So this is the fascicles run in a parallel length. Okay, can be further classified into fusiform muscles and so forth. So these are usually the longer muscles, not all the time. And these are throughout your body as well. The sartorius is a muscle in here that is not one of your quad muscles, but kind of helps a lot with a lot of the control of your hip. Okay. Last one we're going to talk about are the pennate. Okay, so these muscle fiber, the fiber arrangement is not in that true parallel fashion. Okay, so the force generated by pennate muscles exceeds the parallel fibers, exceeds the one like the sartorius here. Okay, because the arrangement varies. Okay, you say the unipennate, okay, as an A. Okay, so an example here is your flexor pollicis longus muscle. This is a muscle that flexes your big toe, long story short. And this is arrangement, so it's not parallel going up and down as the pull of the muscle. It's a little bit of a oblique angle. Okay. And then B, there's bipennate, okay, like the rectus femoris, which is one of your quad muscles, okay, which kind of goes in different directions here. And the last one, your multipennate, like in your deltoid muscle on the shoulder, okay, has multiple different pennates. Like your deltoid has 3 different sections. There's anterior, middle, and posterior sides of your deltoid. So the kind of upside of this is there's more muscle arrangement, okay, which can produce greater forces as a result, even if it's not quite pulling in that same parallel motion. When we talk about the parallel ones, okay, let's say, I mean, I'm just throwing out a number here that's obviously not true, but for the sake, this one's going to have 1,000 fibers, okay? Realistically, this would be more, okay? With the unipennate, okay, that kind of oblique one, you may have 2,000 fibers in there. And then with the bipennate, you may have 2,000 fibers per side. And then you got 2 sides because it's it's 2, bipennate. Okay. In the multipennate, you could have as many as you need to be for that pull. So I can increase that amount of muscle fibers substantially as a result. All right, smooth muscle, okay, located in the walls of your blood vessels, okay, arteries and veins particularly. Internal organs. So this allows for really to build pressure, which is a big one, especially in your blood vessels like arteries and veins. Does help with pumping of blood in itself. This allows your muscles to, your arteries to expand and contract. Okay, so when they either dilate or constrict, that allows more blood flow and can control the pressure in them. And just a doubling of your blood vessels increases the blood flow by about 16 times. Okay, so that's very, very important because as you start doing more motion, let's say you start to go on a run or whatever activity you start to do, your blood vessels will dilate, expand to allow for the need of blood to those muscles or wherever it's going. Okay, same thing because this is involuntary control. So same, your autonomic nervous system isn't responsible for this. So when you get up from a sitting position, your blood vessels usually constrict, and so those muscles, that smooth muscle, and it constricts, which allows that blood pressure to increase to allow you to stand up. When it doesn't do this quite efficiently, what happens is you'll get a little lightheaded for a few minutes, and it kind of goes away. That's actually a form of shock, just because your blood pressure drops so low because your autonomic nervous system wasn't quite prepared for that standing up motion in a way. Okay. All right, there's 4 characteristics of muscle. Okay, contractibility, elasticity, extensibility, and excitability. I didn't quite go in order. Sorry about that. Okay, extensibility, which is just the muscle has the ability to stretch. Okay, usually to a designated length. If it goes beyond that length, usually results in an injury. We call that a muscle strain. Okay, strains can happen to muscles or tendons. Okay, just know that. Sprains happen to ligaments. Okay, very, very distinct thing right there. Okay, so extensibility allows that muscle to stretch. Okay, you can train the stretching. Okay, through like chronic stretching and long-term stretching, you can actually get that muscle more flexible. Okay, and that usually takes a lot of time, and a lot of long-term holds is what the research shows to get that more that flexibility up higher. Usually those holds are going to be about 5-10 minutes each. Doesn't mean you have to do like multiple reps of them, but maybe once or twice a day, like post-workout or whatever it is, you're doing those long-term stretchings. Like hamstring flexibility is always a big one for a lot of individuals. So, so to train that one, you would be, I'll tell people, when you're watching TV, lay on the ground, throw one leg against the wall up high, get a light stretch in for about 10-15 minutes if you can. Okay, so that's going to help kind of train that extensibility of that muscle. Okay, elasticity. Okay, so this is the ability of that muscle to, once it's stretched, to go back to its original length. Okay, now when that muscle is on that kind of stretch, it does store elastic energy, which a lot of times your body will use to produce whatever motion we're trying to do next. Okay, so like let's say when we're jumping, we kind of spring down and load, and we're kind of storing some elastic energy to help us jump higher. Okay, so pretty much long story short is that muscle can go back to its normal length after that being stretched. Okay, the contractibility of the muscle. Okay, this is where it gets a little bit more in depth. So this is where the actin and myosin kind of take place. So here we have a sarcomere. Okay, and the sarcomere is just between these like little Z lines what they have here. And so we have the actin and myosin here. Okay, so the thin filaments and then the thick filaments. Okay, so this is one muscle fiber. Okay, so what the actin and myosin do, okay, is this myosin, which is this kind of tree-like structure, for the muscle to shorten, each little branch of this kind of tree will kind of reach out and grab on to this actin. Okay, so if all these trees kind of branch out and grab the actin and kind of pull itself. Okay, so when it pulls, the muscle shortens. Okay, because these Z lines get closer together as it kind of pulls out. Okay, so the more sarcomeres you have, or muscle fibers that you're using at the time, produces more force. Okay, and then for muscle to elongate, what happens is these branches. Okay, let's say they're pulled in all the way, and then they kind of relax at whatever speed that you're dictating for it. Okay, so that is kind of actin and myosin in a nutshell. Okay, so this is really just how your muscles contract and relax, and it relies a lot on nutrients and like calcium and so forth for this to function properly. Excitability. Okay, so this is excitability is your muscles to respond to some kind of stimulus. Usually it's a electronic and chemical, okay, however you want to dictate it. Both are kind of the same thing. So that motor neuron, okay, innervates those different muscle fibers, okay, or groups of muscle fibers called a motor unit. And that stimulus elicits a contraction, okay, of those kind of actin and myosin. Okay, so what the excitability is just pretty much when that muscle is stimulated by usually a nerve, okay, it contracts or relaxes, however it's dictated. Okay, and muscle recruitment. So when I'm talking about that is if we need to produce more tension on that muscle, you recruit more muscles. Sorry, more motor units, which is this kind of group of muscle fibers here. Okay, so let's say this muscle fiber here is 1, 2, 4, 6, 8, 10, 12, 13 muscle fibers in this motor unit. Okay, so let's say if you recruit one motor unit, okay, I may have enough strength. Let's say this is my bicep. I may have enough strength to lift this marker. Okay, with just one motor unit. Okay, let's say I need to lift a 25-pound weight. Okay, I'm probably going to recruit 50 motor units. Okay, so 50 times 13, however you do the math, okay, to lift that 25-pound weight. Okay. I'm not using all my bicep muscle because I don't need to. Because let's say if my entire bicep muscle contracted at the same time, I would just kind of fling up uncontrollably and not be able to control it properly. Okay. So what muscle recruitment is it just recruits more motor units to produce more tension. Tendons and ligaments, okay? So tendons attach muscle to bone, okay? That's what it is. And ligaments attach bone to bone, okay? Tendons always attach, so there's no direct muscle to bone. It's always via tendon, okay? Always, okay? Each muscle will have a tendon on each side of it, okay? Some have a little bit more tendons, but the ligaments always attach bone to bone, always, okay? Both tendon and ligaments are made up of thick connective tissue, okay, that's able to stand enormous tension, okay? But if whatever that the forces on it exceed the tension that it can withhold, that's where a sprain or strain occurs, okay? Again, a muscle strain, okay, so you can strain a muscle or tendon, and a ligament you can sprain, okay? ESPN always screws it up, just know that. Okay, both become thicker and handle greater tension while handling long-term physical activity. Okay, so you can train, obviously you can train muscles, and you can train ligaments and tendons, particularly. One thing, I mean, I'll probably get more of this later on in the class, on muscles is as you train muscles, because they have substantial blood flow to them, they can grow faster than tendons. Tendons which have little to no blood flow to them grow a lot slower than the muscles, which as results in some form of tendonitis or tendinosis. Okay, it's because a muscle grew too fast or withstood more tension than that tendon could allow at that time. Okay. Usually when an injury occurs, like a muscle strain to any part of the muscle, the ideal spot you want to have is around the muscle belly, which is right in here. Okay. When it's further down on the tendons, it heals slower as a result. But most of the time, the injury is going to be at this muscular tendinous junction, which is just that connection where the muscle and that tendon kind of interact, which still takes a substantial amount of time. A little bit of the anatomy of a muscle. Okay. It's more just kind of terminology, really. Okay. So when we talk about the muscles, there's always an origin and insertion. So the origin is usually the less movable, usually the more proximal end. The insertion is the more movable part, okay, which is usually the distal end. Not all the time, but 9.9 times out of 10. And then the muscle belly, which is kind of that central big bulky portion of the muscle. Okay. So like let's say here on the biceps brachii, okay, the origin up here, because the biceps, okay, bi means two, like bicycle, okay, there's two heads, okay, so there's going to be a long head and a short head here. So the long head's going to attach up here to the coracoid process, the short head's going to attach to the coracoid process, the long head is going to originate at the kind of superior labral section, okay, and then the insertion of your biceps is going to be here on your radialis. Okay, long story short, that's how usually the medical version of us talking about origin insertion. So that's everything for the muscular system in this PowerPoint.